This is Dr. Holt, and this problem is the WebAssign problem number 10. Excuse me, having to do with the horizontal heavy rope. In this example, I have a heavy rope of length of 5.2 meters, has a mass here of 4.5 kilograms. It lies on a frictionless horizontal table. One end is attached to a 6.2 kilogram block. The other end of the rope is pulled by a constant horizontal force of 110. So make this into 110 newtons here, and then over here you're going to have the 6.2 kilogram block, and again this one is going to be the 4.5 kilogram block. Okay, what I did here to find the acceleration, I again drew it just like this. I take the summation of forces is equal to mass times acceleration, make this into the x. And if you run that number here, you'll get 10.28. Now, note, since this rope has mass, the force in this rope will vary. And I can prove that because I know at this end of the rope I'll have 110 newtons. So let's find out immediately what the force would be here. If I drew a free body diagram of the 6.2 kilogram mass, I'd have 6.2 coming down. Let me move that over. 6.2 coming down times 9.8. Draw this and off to the side. Oops. Okay, here we go. So this will be the force of gravity here. Again, that's going to equal to 6.2 kilograms times 9.8. I'll run that number real quick. 6.2 times 9.8. Now this isn't really necessary because we don't have friction here, but I like just to keep practicing determining what the normal force is going to be. So that'll be 60.76. This is my normal. My normal here would equal to 60.76 here. This will be the tension here, and again we know this will be 6.2 kilograms times my acceleration, which is 10.28. Alright, so again I sum forces in the x. So that equal to mass times acceleration in the x. When I do that, I'll get T is equal to 6.2 times 10.28 here. So when I do that, that's going to give me a force, a tension force, T of 63.736 newtons. Again, this isn't necessary to do this, but I want to prove that the tension at this end of the rope is going to be 63.736 right at that point, and the tension here will be 110 newtons. And that's only because the cable or the rope has mass along here. Alright, the second part of the question says give the tension in the rope as a function of the position x along the rope. What I did on this particular problem is I drew myself a small section of the rope. Now the only thing that might be confusing here is I want to find the mass. I'm going to find the mass in terms of x. So what I do is I take the mass of the rope that's given, in this case it's 4.5 kilograms. I will divide that by the total distance there, 5.2 meters. And again, I'll go back to the problem and show you where that comes from. The rope's 5.2 meters long and 4.5. When I do that, that gives me the average mass per unit of length. So if I multiply that by the x distance, that would give me approximately, what the mass of that little section would be based upon what the value of x is. So really all I have to do then is to say that tension that's being applied is equal to mass times acceleration, and the mass is going to be this mass, 6.2, plus 4.5 divided by 5.2 times some x distance here. Now all you have to do there is to solve, and if I do that I will get T is equal to, I'll take 6.2 times 10.28, which is the acceleration. Okay, that's going to give me 63.736 plus 4.5 divided by 5.2 times my 10.28, and that's going to give me a value of plus 8.896 times x. So that's the tension in the rope at a certain distance of x from this particular end. And we'll check that answer and make sure. 63.736. I get 63.7 plus 8.9, which matches exactly what I got. Again, short little video, but it's one problem maybe is a little bit challenging that I thought might affect you guys from finishing the homework tonight. Anyway, hope this helps you. Best of luck.